Hey guys, Kyle here, and today we're going to be constructing a 30-60-90 triangle as well as a 45-45-90 triangle. Starting with the 30-60-90 triangle, there's actually two ways that you can construct this. And so the first way that we're going to do is to just simply cut an equilateral triangle in half. So we'll start with drawing our equilateral triangle. You can really just start with any length, actually, without the compass. Just draw any side. That'll be the first side of your equilateral triangle. And then you have your two points of the triangle. To find the third point, just copy this length, copy the length of the side that you created, and create arcs from both ends of the segment. And the intersection of those two arcs is going to be third point of your equilateral triangle. So if we just connect that up, there's our equilateral triangle. And to get the 30-60-90 triangle, we'll actually get two of them. You just bisect any of the angles. We'll bisect the top angle here. So if you remember how to do the angle bisector, you'll start at the vertex of the angle. Any arc will do, any arc length will do. And from the intersection of those arcs in the side of the angle, draw two more arcs, and then the intersection of those two arcs is on our angle bisector. We'll connect that straight down, and there we have our two 30-60-90 triangles. We know that this is 60 degrees because it's an equilateral triangle. We know that this is 30 degrees because we bisected the 60 degrees. And because it's a triangle, this last angle has to be 90 degrees. Now, the second way that you can do the 30-60-90 triangle is to start with a right angle. So again, just any line segment, any length, and then we will perpendicularly bisect this segment. So here's our perpendicular bisector. And here's our 90-degree angle for our 30-60-90 triangle. Now, if you remember, for 30-60-90 triangles, the side that is opposite the 30-degree side is going to be 1/2 the length of the hypotenuse. And since this segment is bisected, we know we can call this length x. And we know that the whole line segment, or initial line segment, is going to be the length of the hypotenuse, double, or 2x. So if we copy this length and we create an arc, this triangle is a bit large, we know that where the perpendicular bisector meets that arc, we'll just extend this upwards a little bit. Here is going to be the third point of our 30-60-90 triangle. So we just connect that up. And there is a 30-60-90 triangle. Now for your 45-45-90 triangle, we're going to once again start with our 90-degree angle. So draw any segment, and we will perpendicularly bisect it. Again, all of the points on the perpendicular bisector are equidistant from the ends of the segment you're bisecting. So there's our perpendicular bisector. There's our right angle for the 45-45-90 triangle. And then if you remember, for 45-45-90 triangles, since they are also isosceles triangles, the lengths of the legs of the triangles are going to be equal. So if we use this length as our leg, and then we copy that length to our perpendicular bisector, the intersection of that we've just copied that line segment so those two are congruent. And then we just connect those 2 points up, and we have our 45, 45, 90 triangle. Now and that's going to be it for constructing these two special right triangles, and have a great day.